All right, the first thing I want to say is keep in mind that when you're doing these, there's not always one way to do them. So I might do it in a different pattern than yours. And especially with Gaussian elimination back substitution, your reduced or your row echelon might look different. But when you go to plug them back in, obviously, then it should be the same. All right, so what is, usually my first goal is to do what? Get a 1 in that top left corner, right? Which it's already there, yes? So now I want to work my way down, right? Like I try to make like the L shape. So if I try to get a 0 where that 3 is, what's one way I could do it? -3 row 1 plus row 2. So I'm going to take row 1, I'm going to multiply it times -3. -3, 0, 9, 6, 3, 1, -2, 5. And I get 0, 1, 7, 11. And that's going to replace row 2. So 1, 0, -3, -2, 0, 1, 7, 11, 2, 2, 1, 4. Now I want to keep working my way down, so I want a 0 where the first 2 is, and I can do that how?
Row 1 times -2 plus row 3.
Good. -2 row 1 plus row 3. So now I'm doing this one times -2. -2, 0, 6, 4, 2, 2, 1, 4. I get 0, 2, 7, 8. That takes the place of row 3. 1, 0, -3, -2, 0, 1, 7, 11, 0, 2, 7, 8. Now the last 0 I need is where that 2 is. I cannot at that point combine row 1 and row 3, otherwise I lose that first one. So I have to use row 2. I'm going to do -2 row 2 plus row 3. 0, 0, or sorry, what?
How would you lose the 1 if you're...
Because if I add these two after
you'd lose the 0 at the bottom.
you lose the 0, yeah. And there's nothing I can, because there's not usually a 0 there already. There's nothing I can multiply the 0 by. It's going to cancel with a 2. Normally there's still a number there, and those you can't. Once you cancel that 2 out, you would end up putting a number in where that 0 is.
Okay.
So 0, what am I doing? -2 times row 2. 0, -2, -14, -22, 0, 2, 7, 8. 0, 0, -7, -14. And that takes the place of row 3. So I have all my zeros. I just need the diagonal of 1s, which means I have to take that bottom row and multiply it times what? -1/7. So I'm going to get 1, 0, -3, -2, 0, 1, 7, 11, 0, 0, 1, 2. So that is row echelon form, which is where you stop with Gaussian elimination back substitution, because now I convert this into a system. X minus 3z would equal -2. Y plus 7z would equal 11. And z equals 2. And work my way backwards. So I'm going to take this one, plug it in here. Y plus 7 times 2 equals 11. Y plus 14 equals 11. Y equals -3. That's the second variable. And then I'm going to take the z and the y. Oops, there's no y. So I just need the z. X minus 3 times 2 equals -2. X minus 6 equals -2. And x would equal 4. And then your answer you will give me in coordinate point format for -3, 2. That's Gaussian elimination with back substitution. So your test is going to give you one system and ask you to get to that part, solve it, and then you're going to flip the page over, and on the back it says, rewrite your row echelon form from Gaussian elimination back substitution, or the number before it, and then continue to use Gauss-Jordan. So you would come back to this spot, rewrite that as carefully as possible, because if you lose a sign, or obviously it's going to continue to be wrong. And then you're going to continue to do Gauss-Jordan. The good thing is you will be checking your answer, because both of those questions should have the same answer, okay? But you just got to be really careful. If you lose a negative somewhere along the line and you screw up your entire problem and I can't figure out what you did because you didn't give me your row operations, or you're doing stuff in your head, there is very minimal opportunity for partial credit. So keep that in mind. You must write your row operations. You cannot skip steps and do it in your head. That is when even the smartest people make mistakes, and I will not give partial credit for something that you're not showing. All right, now it says, gosh, Jordan. So this is going to be my reduced row echelon. So 2, negative 8, 8, negative 2, 1, negative 3, 1, 4, negative 6, 3, negative 15, 9. So what would you do first?
We didn't have the third. We didn't have the third.
All right, so what would be your first step here? Switch row 1 and row 2. Get that 1 at the top. So you'd end up getting 1, negative 3, 1, 4, 2, negative 8, 8, negative 2, negative 6, 3, negative 15, 9. Now I want to 0 where that 2 is. Easiest way to do it, negative 2, row 1 plus row 2. These cancel, negative 2, 6, negative 10, and that takes the place of row 2. Yep.
Can you show the whole problem again?
Then I want to 0 where that negative 6 is. The top's cut off there.
Yeah.
So I can do what? So 6 row 1 plus row 3. We've gotten really lucky up to this point, and a lot of times when we get to this point, all we have to do is multiply one line to cancel out. Like, let's say I want to put a 0 here, right, which is normally the order that I do it. We've gotten to the point that we haven't had to change 2 equations, but can I change that second row and add it to the third row and have it cancel with negative 15 without having to change? No. So this is a scenario where if you think about your systems of equations, you can change 2 at the same time, right? So if I want to put a 15 there, then I would have to do, and I could do negative or positive, doesn't matter which one, but I would have to do 15 R2, and then I would have to do negative 2 R3. So 15 R2 plus negative 2 R3. So I'm going to have to multiply the second row by 15. 0, negative 30, 90, negative 150.
You could also simplify rows too.
Sure.
Right?
I'm going to show you both ways, though, because it's not always going to,
Okay.
yeah. So then I'm going to do the second row, or the last row, 0, and then negative 2, there would be 30, and then negative 2 is 18, and then negative 2 is negative 66. God bless you. And I get 0, 0, 108, negative 216. You can't be afraid of big numbers, okay? Depending on how you solve your system, you might even have a fraction at some point in your system. You cannot freak out about it. Your answers, I'll tell you right now, for the 3 variables, 3 equations are going to be whole numbers. But it doesn't mean that you're not going to get stuck with a fraction somewhere along the way, okay? You just have to be really careful. And it doesn't mean that sometimes the way that you're doing it is different from somebody else and you've made it a little bit more complicated, okay? So if I continue with this one, then I'm going to rewrite. So 1, negative 3, 1, 4, 0, negative 2, 6, negative 10, 0, 0, 108, and negative 216. So to make my life easier beforehand, I could have taken either this row or this row and simplified it because they're both divisible by the same number. Like I could have done the second row by 1/2, and I could have done the third row by 1/3. But I want you to keep in mind that that's not always going to happen. There are times when you have to multiply both rows to cancel them out. So then what I would do at this point is get rid of this 108, right? So if I did 1 over 108, my system becomes 1, negative 3, 1, 4, 0, negative 2, 6, negative 10, 0, 0, 1, negative 2. Now, again, we just said it. You could either take this row and multiply it by negative 1/2 to get rid of that negative 2, but I need a 0 here, so it might be counterproductive because I might have to do it again anyways. So I'm going to wait until I get my zeros. So from here, I'm going to work my way back up. I want a 0 here. I cannot combine it with row 1, otherwise I lose the first 0. So that means row 3 gets multiplied by negative 6. Negative 6, row 3 plus row 2. And I get 0, 0, negative 6, 12, 0, negative 2, 6, negative 10, 0, negative 2, 0, 2, and that takes the place of row 2. Because if you add row 1 to row 2, you lose this 0. So now I can multiply this, because I have all the zeros I need in that row, times negative 1/2. And I get 1, negative 3, 1, 4, 0, 1, 0, negative 1, 0, 0, 1, negative 2. So because this is Gauss-Jordan, I still need a 0 here and here. It doesn't matter which order you do that in. I tend to follow a pattern, so I go the L down and then work it back up, which means here. But it doesn't mean you have to do it that way. So I would multiply negative 1, row 3 plus row 1. 0, 0, negative 1, 2, 1, negative 3, 1, 4. And I get 1, negative 3, 0, 6. That replaces row 1. One zero's left, and it's here. So I'm going to multiply row 2 by negative 3, or sorry, by positive 3. And add it to row 1. So my ending matrix is 1, 0, 0, 3, 0, 1, 0, negative 1, 0, 0, 1, negative 2. And my solution is 3, negative 1, 2. So I'll say it again, but on your test, you will be working through one system twice. The first time you're going to get to the Gaussian elimination, which is your row echelon, use back substitution to find the first answer. Then you're going to take that same system from the row echelon part and continue to do reduced row echelon. I would not start it all the way back over again. That defeats the whole purpose. And then from there, you'll do Gauss-Jordan and you'll get your answer. So the same answer, like this are questions 11 and 12, should have the same answer. Mm-hmm.
So you're kind of, like the first one's kind of giving us the answer of what we're supposed to get for the second.
If you do it right.
So, well, at least you know if you did it wrong.
Exactly.
Okay.
But if you screw up there, you're so screwed.
Agreed. That's why you're going to be really careful, and then you go back and find your work. Yeah.
Yeah, you
Have
check
extra
it.
time.
On the matrix, I made it, oh no, it's negative 2, right? It's negative 2. Yeah.
This is number 66?
Huh?
What number question is this?
This is the warm-up.
Oh, that's the warm-up? Oh.
Way to be with us, sir.
Oh,
Yeah.
no, because
Oh, you don't. Okay, this is pretty much what you can expect. The good news is that 3/4 of it was on your quiz, right? The last section is just heavyweight because there's 2 questions. I think I did 15 points and 10 points or something like that. So it's a good chunk. So 7-1 was graphing and substitution systems. You are going to be given where you have to graph, but then the substitution, the elimination you can pick through, just like you did with your quiz. Remember those word problems like the interest problems, the break even, the geometric, that kind of stuff. If the lines are parallel, there's no solution. If they're the same line, it's all real numbers. These break even questions are the one you're going to make sure that you round up with. Okay? I don't think I have it on your quiz. I think you had a whole number. Just be prepared that if it's not a whole number, break even rounds up. You're also going to have to come up with your own cost and revenue functions on those. So I think there's an example in the review. I'll pull it up in a second. But you're going to have to produce your own revenue. I'm not going to give it to you this time. You're going to say cost equals the amount of money it costs to make it plus whatever upfront cost there is. And revenue is whatever you're selling your units times that X. Andy?
Are we gonna get our quizzes back?
Yeah, so the last makeups, that's why I'm forcing them to come today after school. The last makeups are coming today after school, and then tomorrow you'll get your quizzes back.
What if we don't come?
Then you get a 0.
Actually.
Yeah.
Well, my grades
Yeah.
are not bad.
All right, and then 7-2 is an elimination. This is the one, again, you can kind of go back and forth between elimination and substitution. I didn't force you to do one or the other. If all the variables cancel and it's a true statement, then it's all real numbers. If it's all the variables cancel and it's a false statement, it's no solution, which is the same as substitution, okay? And the word problems in this case were like your equilibrium point. Like if you had to sell X amount of units, at what price, find your equilibrium point.
So demand supply.
Yes, yeah.
The quiz is also scientific calculation?
Yep.
How many
Uh,
questions is it?
The test is 12.
Okay.
Yeah.
So we can use the scientific.
The whole time. Yep. And then 7-3 is 3 variables with the partial fractions. So you're not going to do the new 1, new 2 method. There's just not enough time to do that and the matrices. So from 7-3, that's on your quiz, the new 1, new 2 method. But we're replacing it with the matrices for your test. There is the partial fractions. So keep in mind, still no repeated factors. But on your quiz, you only had 2 equations. If you remember, this was only A and B. There was not a third term. You need to be ready for a third. You're going to be 2 questions, one with 2 terms, one with 3 terms. So you got to be ready for that for your test. And then 7-4 is exactly what we just talked about. Gaussian elimination with back substitution. Rewrite the row echelon form and finish it with Gauss-Jordan. So you're finishing that question twice. Both answers should be the same. Scientific calculators the whole time. If your scientific calculator has a matrix button, so be careful because those, like a function calculator, you won't be able to use. The rest of them are fine. So it's a scientific and not a function calculator. If you have a question, make sure you have it with you tomorrow. I will let you know if it's okay or not okay. Questions as far as expectations go? Okay. So you want me to work through a partial fraction one? Spend a little bit? Okay. All right. So I'll give you 1 with 3 variables. So let's say.
Wait, for the test you said the ones where it's like new 1, new 2, it's not on the test? Or you said
It is not on the test. The matrix is taking over those.
Okay. So for 7-3, it's basically just the
Partial fractions. 2 questions for partial fractions.
But on the quiz.
On the quiz, there's a new 1, new 2. Okay, so let's say this is your partial fraction one. Directions are just going to say use partial fraction decomposition. That's it. So the first thing you want to do is what? Factor the denominator. What can you do first? Take out an x. Can you factor it further?
Yeah.
Good, because otherwise that would have been, I wrote it wrong. X minus 5, x plus 2. So there's 3 terms. 1 gets the A, 1 gets the B, 1 gets the C. Okay, then comes, how do I plug in? You can either look at these, right, and say what's missing. This would be x plus 5, x minus 2. This is x and x plus 2. This is x and x minus 5. So I'm going to rewrite those numerators. 3x minus 2 equals A. X plus 5, x minus 2. B, x, x plus 2. C, x, x minus 5. I'm telling you right now, if you don't practice these, you're going to get hung up on them. It's going to kill your time. If you practice these, it's the same pattern every time. You should be able to do this question relatively quickly. Don't let this hang you up. So, yeah.
Isn't it X minus
Did I write something wrong?
two?
Isn't it X minus 5?
-5. Oh, the first one. Yes, thank you. This should be minus m plus. Okay, so now I want to figure out what I have to plug in. And this, when there's 3 variables especially, it's easier to go back to your original fractions and set all your denominators equal to 0 and know that whatever you solve for, that's what you're going to plug in. So I'm going to have to plug in a 0, I'm going to have to plug in a 5, and I'm going to have to plug in a -2. So when x is 0, when x is, what did I do it in order? -5, right? Or +5. And -2. Now, instead of rewriting that sucker out every single time, this is where the practice is going to come into play. I should be able to know that if I plug in the 0, which of them are going to cancel out. So it always gets plugged into the left side. But then when I look here, the 0 and the 0 are not going to cancel, so the A is the one that's going to get kept. If I plug a 0 in here, B is canceling. If I plug a 0 in there, C is canceling. I don't even need the rest of it. Don't waste your time writing it over and over again. So I'd get 0 minus 2, which is -2, equals A, -5, 2, A, -10. A is -2 over -10, which becomes 1/5. Yep, sure. Then I'm going to plug in the 5. So 3 times 5 minus 2 would equal, the 5 in on the A is going to cancel out the A, but the B, it will stay. And the C, the 5 on the C is also going to cancel out the C. So I don't have to write the other 2. Now I've got my B. We good so far? Then I go to -2 is the last one. 3 times -2 minus 2 equals, -2 is going to cancel with the A. It's going to cancel with the B, but it's going to be okay on the C. So now I've got my A, my B, my C, and the last step is to carefully plug them back into the one that they're supposed to go in. So the A is the one that goes over the X, so it's 1/5 over X. The B is what goes over the X minus 5, so it's 13/35 over X minus 5. The C goes over the X plus 2, -4/7 over X plus 2. I cannot leave a fraction within a fraction, and I cannot leave the numerator, the negative. So this 5 is going to come down to the bottom here, 35 here, 7 here, and that negative is going to become a minus. So I get 1 over 5x plus 13 over 35 times x minus 5 minus 4 times 7 over x plus 2.
Solve more than that.
Nope. You don't want to distribute. It actually makes it less simplified, so I definitely don't want to distribute. If they were all like the same factor on the bottom, if they are all 5 in the bottom, maybe I take out the 1/5. But don't make your life complicated and try to make them all 35 and then take it out. Like you're making more work for yourself than you need to. If it was standardized tests, they usually factor out the greatest common factors, so they would like change them all so they have 35 in the bottom and then take it out. But an open-ended question, I'd actually prefer you leave it just the way that it is. This is a test question. The quiz, we only did 2 factors. We didn't do 3. Test, you will get 2 and 3. Yep.
If you have time,
Those are fun.
can you go over 1 and 6?
Yeah, sure.